How to find the area under a curve. This is the sigma symbol. It is used as an alternative form of writing complex equations. Our equation is x to the power of 3 plus 4 with the boundaries of 1 is less than or equal to x, which is less than or equal to 4. The first steps for finding the area under the curve for this equation is 1. To graph the equation, 2. To find the left and right point rectangles, and 3. To average the areas of the left and right endpoint rectangles. This is our equation when graphed. This is our graph for the lower bound, or left endpoint rectangles. The width of each rectangle is 0.6, this is the change in x, and you find that by subtracting 1 from 4 and then dividing by 5. The next step is finding the area of each rectangle by multiplying the width, 0.6, by the height, which is different for each rectangle. To find the full approximate area under the curve, you must add the areas of each individual rectangle together. This is the graph for our upper bound or right endpoint rectangles. The width of each upper bound rectangle is the same as all of the lower bound rectangles, but the height will vary. The process for finding each of these rectangles and the approximate area under the curve is the same as for the left endpoint rectangles. The sigma notation for the left endpoint rectangles is 4 over the sigma, k equals 0 under the sigma, and adjacent to the sigma there is parentheses, parentheses, 1.6k, end parentheses, plus 4, end parentheses, parentheses, 0.6, end parentheses. So, to get n, which is the number over the sigma, you subtract 1 from your number of total sections or rectangles, which in our case was 5. K equals, which is below the sigma notation, will be 0, and to find the equation adjacent to the sigma, we take the original equation and plug in change in x, in our case 0.6 sub k, plus 1 for x. Then we multiply the entire equation by 0.6. The sigma notation for the upper bound rectangles changes in two ways from the lower bound. The first way is the n, or the number above the sigma, changes from 4 to 5, and k equals is 1 rather than 0. To find the area under the curve, we must take the approximate area under the curve from both the left and right endpoint rectangles, and then take their sum and divide it by 2, and that will give us the average of the two areas, which will in turn give us the area under the curve. And in our case, the area under the curve is 77.1.